Hey everybody, welcome to our next review. And again, it's on expressions and equations. It's on solving systems of equations. So solve the system using substitution and equal value methods. Be sure to write your solution as an ordered pair in the form of xy and check your solutions. Show all of your work. So this is the big gist of chapter 5. So the first thing I want to do is I want to double check, make sure, they're both equal to y. And that's important because if y equals this and y equals this, that means that 2x minus 4 equals negative 5x plus 7 because they both equal y. So what we're going to do is we're going to take this and we're going to replace it with that y because they're equal. And that's why they call it the equals value method. Technically, it's substitution method as well because we substituted y in for this. So now I just solve it like any other problem we've been solving all year long. So I'm going to add 5x to both sides. 5x plus 2x is 7x. 17. I'm going to add 4 to both sides because I want to isolate the x, the variable. So it's 7x, and then 17 plus 4 is 21. Now, and 21 divided by 7 is 3. One of the most common mistakes I get is people will stop right there. You're solving a system of equation. And remember, a system of equation has to be a set of coordinates or an ordered pair. So now I have to find what y is. Now I can use any one of these to do it, and I'm going to use this one right here. So I know that y equals 2x minus 4. And if I substitute in 3 for x, I know that y equals 2 times 3 minus 4. 2 times 3 is 6. 6 minus 4 is 2. I know it's going to be 2. Now, you might be asking, well, what if I use the other one? Well, let's use the other one. Let's use the top one. Y equals a negative 5x plus 17. And if I know that x equals 3, it's negative 5 times 3 plus 17. Negative 5 times 3 is what? It's a negative 15 plus 17. Y equals 2. So it doesn't matter which one I plug this into. They both should equal the same. And you can always check. And if you do both and one equals 2 and the other one doesn't, you know you made a mistake somewhere. And it doesn't work. So circle your answer. That way I know exactly what to look at in a test. So here we have another one. Again, they're both equal to y. So I can say 3x minus 7 equals x minus 1. Now, does it matter what side these are on? No, I could have x minus 1 over here equals 3x minus 7 over on this side. It does not matter. I'm going to simply subtract x from both sides. So it's 2x minus 7 equals a negative 1. Add 7 to both sides. 2x, a negative 1 plus 7 is what? 6. Divide both sides by 2. X equals 3. Remember, you're not done yet. That's just one of my ordered pair. That's my x. So what do I have to do? I have to plug it in for one of these. And I'm just going to do x minus 1. Now, on the test, would you have to show me plugging this in? Absolutely. Otherwise, I don't know how you came up with that answer. So y equals 3 minus 1, which is, what do you think that is? 2. Could they both be 3, 2? Let's double check. So I'm going to plug it in the other one just to double check. 3x minus 7. 3 times 3 minus 7. 3 times 3 is 9. 9 minus 7 does equal 2. So there is my answer to that system of equations. So both of them are here. I list both of them as a set of coordinates, and that's important. I checked my solution. I did everything I need to. Now, theoretically, I could put 3 in for both of these. I could put y in for these, and they should all equal, just like we normally would. So as always, if you have any questions, make sure you ask. Don't go into the test not knowing when you could simply ask a question and hopefully know. So thanks, and bye.